Okay, so good evening to all of you. So we are now. I'm starting today this understanding the structure of an atom, and the simplest atom is hydrogen atom. So we'll try to understand how we can, with the help of quantum mechanics, how we arrive at the structure of the atom, the energy and other description, momentum, everything that we can. So basically, understanding atom basically it means how the electrons are arranged, how what is its energy. That is the mainly the thing that we try to understand in this case. And so, so as you know, atoms are the basic building block for all matters. And so we have to understand whether it's physics, chemistry, or biology. You have to understand the atoms. And in that effort, uh, so we are making an effort for that. So you have already, so this is something that you know from your class 11th, what you studied in early days. आपने सबसे पहले जब पढ़ा होगा 11th class में, at that time you must have learnt about these things, how the electrons were discovered, how the protons were discovered. So just a quick recap of what you already know and how it was discovered and all that. So it was, the name of something. So J.J. Thomson was the person, the scientist who discovered electrons. How it was discovered? So if you look at it, the picture, just a moment, is that? Who is remind later? Please. Hello. Okay, so here. So हम लोग क्या कर रहे थे? So this is, look at this picture carefully. If you can see this. So this is, here you have there is a cathode here. You can see that. और यहाँ पे एनोड है, एक डिस्क जैसा जो दिख रहा है वो दैट इज एनोड, और उस एनोड में छोटे छोटे होल्स कर दिए गए हैं. इट इज अ परफोरेटेड एनोड, वी कॉल इट परफोरेटेड एनोड. देन what happens? So normally in a cathode ray tube, what happens? There is a beam which travels through this from cathode, from the negative end of the pole, negative terminal to the positive terminal, like that. So the beam that is, because there is perforation, there is hole in the in this disk, एनोड में जो होल है उसके थ्रू रेज इसके आर पार ऐसे चली जाती है. देन if you try to understand what are this in this tube, the rays that are emitted, what is the nature of that thing, then it is, you apply this positive plate, negative plate, if the ray was found to be bending uh, towards the this positive plate. So it was it tells you that something is, there is something negatively charged contained in that. अगर पॉजिटिव प्लेट की तरफ बेंड कर रहा है मतलब उसमें नेगेटिव चार्ज है. और दूसरी चीज, अगर आप मैग्नेट लगा दें, then it was found to be bending. So uh, in the magnetic field, that means it consists of charged particles. So first observation was with the magnetic field. When you apply magnetic field, the ray bends. That means it consists of charged particles. And what is the nature of charge? That was known. That can be determined when you apply this electric field. So electric field apply करने पे positive plate की तरफ bend किया. So that means it consists of negative charges. And then nature of cathode change किया गया. So different metals का cathode लिया गया. हर बार वही result आया. The results were same irrespective of the nature of cathode element. So that led to the third point, that it is very fundamental thing. The particle that is emitted is a fundamental particle, and it constitutes all matter. It is present in all matter. So that it was named as electron. As you know now, the electrons were discovered. This is how. So एक कैथोड रे ट्यूब में परफोरेशंस किया गया, छेद उसमें होल्स किया गया, और उसके थ्रू जो बीम पास कर रही थी उस कैथोड रे को एनालाइज किया गया इलेक्ट्रिक फील्ड में, मैग्नेटिक फील्ड में. मैग्नेटिक फील्ड में जाने से ये अगर वो रेस अगर बेंड कर रही है, दैट मीन्स इट कंसिस्ट ऑफ चार्ज पार्टिकल. जो फंडामेंटल मैग्नेटिज्म आपने पढ़ा है उसमें यही है कि एनी मूविंग चार्ज पार्टिकल will be will generate magnetic will be having magnetic moment, and so it will be attracted to the poles of the magnets. So it is due to the motion of the charged particles that the basic thing that q v cross p. So the fundamental thing that a moving charged particle, that's how. So if there is change in the path of the thing, this thing, then that is how. So that leads to the first conclusion, that charged particle is present. It has what is the nature of the charge? Negative. And if you change the cathode material, every time the results are same. So that is a very fundamental. ये पहली चीज जो हमें समझ में आई. और इसी तरह से फिर आपने तो जे जे थॉमसन ने अपने हिसाब से एक मॉडल सजेस्ट किया, फर्स्ट एटॉमिक मॉडल. तो उसने कहा कि बस अगर ओवरऑल तो एटम न्यूट्रल है, तो पॉजिटिव चार्ज समथिंग लाइक दिस प्लम पुडिंग मॉडल. सो ये सब चीज़ें तो बहुत पुरानी होगी. देन यू ऑल्सो नो हाउ द protons were discovered. It was the nucleus discovery of, or rather we say the nucleus was discovered by Rutherford's experiment. You must have read about the famous gold foil experiment. So I think so. I'm not going into the details because you just ये सब आपको बहुत पहले आपने 11th में पढ़ा होगा, सब ये ध्यान होगा. So you know most of the. So what he found was very important, that the beam of alpha particles that passed through the gold foil, it was most of it was smooth passage. It went through, but some of them were deflected. Okay, so deflected through, and this led to conclusion that there's something positively charged at the center. A few of, and that is what later on came to be known as what we know as proton. So again, he suggested his own model of atom, but that there is a proton at the center and electron is moving around. But the the classical Maxwell theory of electromagnetism tells you that if there is any moving charge, अगर कोई moving particle है, moving charge है, और वो circle, if it is constantly accelerating, then it will radiate out energy. This is classical Maxwell theory of electromagnetism. So if electron is moving like this, then it must be continuously losing energy and ultimately it will collapse. So again, something like this. So till that time it was so there is nothing like that happens. The electron never collapses into the nucleus. So that uh, that way the time calculated based on the classical electromagnetism theory was that about if this is something like this structure, then it will collapse in 10 to the power minus 8 seconds, but nothing like that happens. So Rutherford, for the discovery was okay, electron is there, there is a something positively charged, but the structure was not correct, something was missing. Okay, then it comes the spectroscopy. So spectroscopy, spectroscopy is the still the tool which by which we are able to know the structure of an atom, the energy, the everything, the momentum, वो सारी चीजें आपको स्पेक्ट्रोस्कोपी के थ्रू ही आती है. So how do we do that? So this is what I told you, that you pass the radiations. So that's the next part that we will understand. Actually, we have discussed already while starting the quantum mechanics classes. I introduced you I told you about the three crucial experiments, and one of them was this, the spectrum of hydrogen atom, which was found to be. So this is something that I had already explained to you, the discharge tube experiment. What happened in that? In the picture, यहाँ पे क्या दिख रहा है? There is a glow around the discharge tube. Why there is a glow? वो ग्लो क्यों है? अब ये सब आपको बिकॉज मैंने बताया हुआ है, आपको पहले से थोड़ा तैयार रहना पड़ेगा कि यू मस्ट बी डू समथिंग, कैचिंग अप, रिवाइज योर थिंग्स. जो मैंने आपको पहले शुरू की क्लासेस में बताया है उसको आप रिवाइज कीजिए. ये ग्लो क्यों दिख रहा है? व्हाट वाज देयर इन द डिस्चार्ज ट्यूब? व्हाई यू आर सीइंग दैट ग्लो? नाउ आई शुड आस्क यू द क्वेश्चन बिकॉज आई हैव ऑलरेडी एक्सप्लेन दिस थिंग्स टू यू, राइट? सो ये जब एक्सपेरिमेंट हुआ, इससे क्या पता चला? व्हाट वाज द थिंग? दैट एनर्जी ऑफ द हाइड्रोजन एटम, द इलेक्ट्रॉन दैट इज देयर, इलेक्ट्रॉन की जो एनर्जी है ये कंटिन्यूअसली चेंज नहीं कर रही है, इट इज डिस्क्रीट. ये आइदर दिस, जितनी बार एक्सपेरिमेंट किया गया वहीं पे लाइंस आई, रेड, ग्रीन, यही सब लाइंस ऑब्जर्व किया गया फोटोग्राफिक प्लेट पे. सो द एनर्जी कैन of the electron cannot change continuously as suggested in Rutherford's model, like this continuous, there is no continuous emission of light. एक continuous band नहीं मिला था, तो इसका मतलब continuous band, अगर ये continuously धीरे धीरे एनर्जी लूज करता तो आपको एक continuous spectrum मिलता, वैसा नहीं मिला. and what you got was either this emission. फर्स्ट जो एक्सपेरिमेंट हमने जो किया गया था स्पेक्ट्रोस्कोपी में, दैट वाज एमिशन स्पेक्ट्रम, लाइट एमिटेड बाय द डिस्चार्ज ट्यूब. डिस्चार्ज ट्यूब के अंदर क्या था? हाइड्रोजन गैस. हाइड्रोजन गैस, नाउ यू नो व्हाट वाज देयर? H2. अब आपको पता है कि अगर उसी एक्सपेरिमेंट को अब आपकी जो नॉलेज है उसकी बेसिस पे एनालाइज करेंगे तो उसमें क्या था? H2 एट वेरी लो प्रेशर पे लिया गया, वेरी लो प्रेशर. एंड देन व्हाट हैपेंड? इट वाज व्हेन यू हैव इलेक्ट्रिक डिस्चार्ज, व्हाट हैपेंड? इट broke up into two hydrogen atoms. This hydrogen is excited state. ओके, सो जो इलेक्ट्रिक डिस्चार्ज दिया गया उससे वो हाइड्रोजन एटम्स में बन गया, और ये दिस स्टार्टेड कम्स बैक टू द ग्राउंड स्टेट एंड रेडिएशन इज एमिटेड. ये आपको समझ में आ रहा है कि ये चीज जो है, एंड सो यही आप रेडिएशंस को फिर एनालाइज करते हैं. सो जो ग्लो दिख रहा है ना, द ग्लो इज बिकॉज excited hydrogen atoms are coming back to the ground state, and in the process they emit out the equivalent amount of energy in form of light, in form of light, and that light you are passing, making it pass through prism. You are trying to identify what are the components present. यही आप कर रहे थे। और जो उस समय किया गया, तो जितनी बार भी एक्सपेरिमेंट परफॉर्म किया गया, हर बार वही लाइन, रेड, ग्रीन, ब्लू और वॉयलेट, यही लाइन उसी पर्टिकुलर पोजीशन पे फोटोग्राफिक प्लेट पे मिला। Okay, so that tells you that the energy, no matter what you do, the energy of the electron in hydrogen atom is not changing continuously. It can either have this energy or this particular value of energy when it is moving uh, from uh, from one state to the another state within the atom. So something like this. So this led to that energy is quantized. This led to the conclusion that energy of electron in the atom is quantized, and this we have already discussed these things earlier at the very beginning. ठीक है। और वही चीज जब उल्टा, अगर आप रिवर्स वे में सोचें कि एक्साइटेड एटम नहीं है, आपके पास ग्राउंड स्टेट में हाइड्रोजन एटम है, और तब आप उस पे यू आर इरेडिएटिंग अ वाइट लाइट। अगर वाइट लाइट पूरा फोटोग्राफिक प्लेट पे जाता तो कंटिन्यूअस स्पेक्ट्रम बनता, ठीक है, ऐसा। लेकिन जैसे ही आपने उसके बीच में सैंपल हाइड्रोजन एटम डाल दिया, तो वो वहां पे वो मिसिंग लाइंस विल बी मिसिंग, एंड सो देयर विल बी नो लाइट रीचिंग द एट दैट पर्टिकुलर पॉइंट। उसी पॉइंट पे वहां पे आपको ब्लैक अपीयर्स। ब्लैक वो पहले से ही फोटोग्राफिक प्लेट ब्लैक ही होता है, और उस पे ये कलर्स जो आपको आ रहे थे, लाइट जहाँ पे पड़ रही थी वहां, तो अगर वो लाइट एब्जॉर्ब हो गई तो फोटोग्राफिक प्लेट पे पहुंचेगी ही नहीं, इसलिए वो, तो जहाँ पे एमिशन स्पेक्ट्रोस्कोपी में आपको ब्राइट लाइंस दिखी थी, उसी जगह पे एब्जॉर्प्शन में, एब्जॉर्प्शन स्पेक्ट्रोस्कोपी में आपको डार्क लाइंस दिखेंगी, बाकी कंटिन्यूस। So these two things, the absorption and emission spectrum, this is the real emission spectrum of हाइड्रोजन एटम। ठीक है, इसी तरह के एक पर्टिकुलर डिस्टेंस पे ये सब गैप पे वही सारा मिलता था। ये आपका टिपिकल है। ये कोई स्कीमेटिक डायग्राम नहीं है, ये रियल फोटो है जो एक एक्सपेरिमेंट में जनरेट होता है। ओके, एमिशन स्पेक्ट्रम। So that was the first thing which was discovered, Balmer series, you know, simplest atom। और यहीं से theoretical modeling start होती है। The first theoretical model was in this way, discovered by Balmer, and then he formulated empirical equation, he made something like this सो बामर सीरीज सबसे पहले क्यों बामर ने जो डिस्कवर किया था वो जॉन 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 बामर। सो इट वाज विजिबल रेडिएशन। सो इसके लिए, क्योंकि सबसे पहले ये डिस्कवर इसलिए हुआ क्योंकि योर आईज आर द डिटेक्टर, you don't have the instrumentation, as the instrumentation developed, more and more sophisticated detectors were built, and then it was also found that some of them contain ultraviolet radiations. There are also ultraviolet radiation contained in the uh, spectrum। so ये सब बाद में डिस्कवर हुआ। सबसे पहले so first thing was the discovery of Balmer in 1885, because for that you need only your eyes are sufficient to discover the lines red, green, blue, but in case of ultraviolet or infrared lines you need a very sophisticated detector, your eyes can't detect them। so एक सिंपल सा इक्वेशन, ये सब जो है रिडबर्ग इक्वेशन आप जानते हैं, इसको किया गया था। so this is how it came out। so these are the things, so that empirical equation that Balmer initially developed were further modified and it came out to be something like this, so as a function of 1 by lambda। okay, so all these experiments, spectroscopic experiments are performed on hydrogen atom, were fully explained by the model that was proposed by Niels Bohr, And see, again, these are very elementary things. I expect you to know your in your 11th class, in your BSc first semester. These are things that is usually taught. So I'm not going into the much of the details of the Bohr's model, but एक ओवरऑल चीजें आपको पता होनी चाहिए कि बोर्स मॉडल में था क्या. He considered electrons to be moving around the nucleus, and he said that as long as the जब तक वो इलेक्ट्रॉन मूव कर रहा है in that it is moving in that circular path around the nucleus, its energy will be constant. It will not radiate out any energy. So that was his first assumption, and that's he gave this concept of stationary states. हर ऑर्बिट में एनर्जी. सो ये सब चीजें आपको पता है. एंड द डिफरेंस, द लाइंस दैट वी सी इन द स्पेक्ट्रम is a result of the transition that electron jumps from one orbit to the other. So that is what initial to final, final to initial, initial to final position, and that is the equivalent radiation is given out. Okay, so that was the observations of Balmer, Lyman, and all that was perfectly explained by Bohr's theory. Okay, he also accounted for the angular momentum of the electrons, that was h by 2 pi, or simply we call it h bar, h by 2 pi. And he also said that at very high quantum numbers, so these are the things that he there were certain numbers that he said that this angular momentum is a can change by the multiple of n h by 2 pi, something like this. So and these numbers quantum were called quantum numbers. So these are things that you know. I'm not going into the rest of the details of this Bohr's theory, but there was one very basic thing that was he was not able to explain. uh, so this was fine till for hydrogen atoms. ये बहुत अच्छा था, थ्योरी एक्सप्लेन कर रहा था. बट जैसे अगर वो थ्योरी सही है तो सारे एटम्स के लिए इक्वली एप्लीकेबल होना चाहिए, बट इट फेल्ड with multi-electronic systems, and it also failed for isotopes of hydrogen. There was certain discrepancy. The lines, electronic arrangement is the same, nucleus is the same, electrons is the same. So how come the lines was found to be slightly shifted? So that was also not explained by Bohr's theory. So, but at least you first, at a beginner's level, we expect you to understand the Bohr's theory very well, and then only you start moving to the quantum theory. So he said that these are the energy levels. So see, n is equal to 1, 2, 3, 4, 5, 6. So this is the variation in n, and the lines are going like this. The pictorial view. So you see, this is the n is equal to 1 first orbit, 2, this is the second, third, and so on. n is equal to 3. ओके, तो ये आप देख रहे हैं. तो जो बाबर ने ऑब्जर्व किया, व्हाट वाज दैट? द ट्रांजिशन, द विजिबल रेडिएशंस was something that was when the electrons in the higher energy state, like here, if they are coming back, returning back to the second n is equal to 2 state, that is giving you these visible lines, visible radiations. In pictures here you can see this. These are the cause of the visible radiation, the Balmer lines in the spectrum. So blue light carries more energy, so you see greater this difference of energy because of this, and the smallest difference is the red light between n is equal to 3 and 2. Okay, so that you can clearly see. अच्छा, एक और चीज ध्यान दीजिएगा, why all the energies are in negative. Negative क्यों है? The maximum energy here is 0. Why it is 0? So why it is considered taken like this? हमेशा एनर्जी ऑफ एटम, इलेक्ट्रॉन जो हम दिखाते हैं हाइड्रोजन एटम में, वो नेगेटिव होता है इलेक्ट्रॉन का, और मैक्सिमम जब n इक्वल टू इन्फिनिटी होता है वहां पे 0 हो जाता है. ऐसा क्यों दिखाता है? आई थिंक यू नीड टू अंडरस्टैंड हाउ it was. ये दिमाग में आपके क्वेश्चन आना चाहिए था, why the energy is negative for electrons, क्यों? So for this, to answer this, you must try to understand what so first consider how. So imagine you know the fundamental particle is proton, there's another fundamental particle electron, and these two constitute the hydrogen atom. So imagine how मतलब वो हाइड्रोजन एटम कैसे बना होगा. इमेजिन कि अगर एक प्रोटॉन और एक इलेक्ट्रॉन होगा इनिशियली टू स्टार्ट विथ, then how slowly they come together and form this hydrogen atom. ये कैसे हुआ होगा? So let's start with a point here. Let's there be a proton, let there be an electron. Okay, and suppose they are, the distance between them is infinite separation between the two. This is at rest, this is at rest. तो इलेक्ट्रॉन और प्रोटॉन इनफाइनाइट डिस्टेंस पे हैं एक दूसरे से, और दोनों रेस्ट पे हैं. सो व्हाट इज देन द काइनेटिक एनर्जी ऑफ द सिस्टम? 0. काइनेटिक एनर्जी इसका भी 0. potential energy, because they are at infinite distance, so no interaction between the two, potential energy is also 0. Now suppose if you push them towards each other, they will start experiencing the force of attraction. दोनों के बीच में एक force of attraction होगा. So suppose there is some distance that is, so now there will be the potential energy, it will attraction energy decreases. So because of the attraction between, when the distance is not infinity and they are just slightly, they feel attraction of each other, and so the energy will decrease. So because of this you expect energy to decrease. Energy will decrease. So if the energy decreases, it is already 0. The energy of the total energy of the system. So let's see, like initially, so 1 2, in the first case the potential energy of the system is 0. Now because of this attraction the potential energy will further decrease, so it will become less than 0 because of the so it will become turned out to be negative. So in this manner, somehow it will, from the Bohr's point of view, Bohr's theory point of view, the electron and proton will be arranged at an equilibrium distance, and this is what you constitutes an atom, right? So एनर्जी तो नेगेटिव ही होता जाएगा, जैसे जैसे वो पास आते जाएंगे दे विल बी further decrease in energy and potential energy will keep on decreasing, so you have total energy will turn out to be negative. Okay, so that was the thing that what we understand now. So what was the energy, how the energy is released? So you have electron in the outer orbit, and then it goes to some inner orbit, and the energy is emitted in terms of h mu. So difference between the two, to give out h mu is equal to the difference of energy between the two orbits. So this is the idea that explains the experience. So what was the limitations of Bohr's theory? As I already told you, it is perfectly fits for hydrogen hydrogen atom. It is also okay for one electron species, others like helium plus, lithium 2 plus, but it is not able to explain anything. For multi-electronic system it failed. Multi-electronic system में ये fail कर गया पूरी तरह. And it was also not able to explain why the spectrum appears as a double lines if the discharge tube is placed in a magnetic field. ये सब जो जीमान इफेक्ट था, जो कि बाद में डिस्कवर किया गया, लाइंस का स्प्लिटिंग देखा गया इन मैग्नेटिक फील्ड. So all those things were not explained even in case of hydrogen atom. तो वो सब, तो इन सब मल्टी, सो यही था. अभी एक ही एटम की बात हम कर रहे थे, हाइड्रोजन एटम, और उसी उसमें भी बहुत सारी चीजें अनएक्सप्लेन्ड रहने लगी. सो देयर इज समथिंग दैट वी वर मिसिंग आउट. द Niels Bohr must have missed out something very very fundamental, which people were trying to find out कि क्या मिस हो गया. So then ये जो ट्रीटमेंट ऑफ इलेक्ट्रॉन है ना, सो समथिंग विच व्हाट वी इट वाज रिलेटेड कि इलेक्ट्रॉन एज अ पार्टिकल only as a particle. Yes, somewhere it was found that it is not correct. Treatment of electron as particles, it is not sufficient enough to account for the properties. The biggest failure of Bohr's theory was that he was not able to answer why is the energy quantized. Why is the energy quantized very precisely? उसने कहा कि वो सर्कल सर्कल में घूमेगा तब तक उसकी एनर्जी फिक्स रहेगी. क्यों फिक्स रहेगी, क्यों चेंज नहीं होगी, उसके बारे में कोई आइडिया नहीं था. Why the energy will be quantized, there was no explanation. So this is the biggest drawback of Bohr's theory. Then, as we discussed in previous classes on quantum mechanics, in subsequent years following the Bohr's theory, we had de Broglie who came up with this idea of what we say wave particle duality. Actually I also discussed, आपको याद होगा हमने वो भी डिस्कस किया था कि एक फंडामेंटल नेचर पाया गया सब में, उसके बाद ये थ्योरी आई थी डी ब्रॉगली की जो इक्वेशन आया. एक हाउ डिड इट ओरिजिनेट, देयर वर टू एक्सपेरिमेंटेशंस. photoelectric effect, so light which was considered as wave till that time, it showed particle like behavior. And then there was also electrons as which was considered as particles till that time, also showed wave like behavior. Wave like behavior कैसा, diffraction pattern, याद कीजिए ये सब मैंने आपको बताया है, diffraction patterns ऑब्जर्व किया गया था. So all those things led to the understanding क्या, which understand that all these particles that there is dual behavior. Fundamental particles like electrons show dual behavior, and we cannot ignore it. It is particle as well as waves, and somewhere we were missing out on the wave part. We were totally neglecting the wave nature of electron, and that's why we were failing to explain the as per the Bohr's model. It was failing. So वो जो हम visualize नहीं कर पा रहे थे, we were not able to. Okay. सो ये सब सारी चीज़ें हमने पहले की क्लासेस में डिस्कस किया है. सो दिस वेव पार्टिकल डुअलिटी विच इट इज, ये एक नई चीज, यही दिस इज समथिंग दैट strikes at the heart what we say, that it is the soul of the new theory that was about to be developed, which we now know as quantum mechanics. सो ये एक बहुत बड़ा पॉइंट था वेव पार्टिकल डुअलिटी के लिए, और जो इक्वेशन दैट ही प्रपोज. सो डी ब्रॉगली ने ये कहा कि सिर्फ इलेक्ट्रॉन ही नहीं, कोई भी चीज, एनी मैटर, इवन आप और हम भी जब मूव करते हैं, वी ऑल्सो हैव, एवरी मैटर हैज अ वेव लाइक कैरेक्टर, बट द एक्सटेंट, वो जो प्रॉपर्टी है उतना डोमिनेंट नहीं होगा. ठीक है. एंड दैट लैम्डा यू कैन फाइंड आउट फॉर एनी मूविंग थिंग. You can find the lambda by this. So if you try to calculate it for electron's mass is known, and assume it to be traveling at the speed of light, then if you try to calculate lambda, it turns out to be 24.2 picometer. So this electron, which is significant, as the mass becomes larger, you can expect lambda to be much smaller. अब इतना छोटा हो जाए कि फिर हम मेजर ही ना कर पाए, तो वैसी सिचुएशन में कोई फायदा नहीं है उसमें. सो smaller the particle, uh, it was becoming more and more significant, the particle wave nature of the thing. So electrons, so we if we have to understand the property of electron, we cannot ignore the wave characteristic and the diffraction. So this photoelectric effect and the diffraction pattern, I already told you about this. These were the basic Davison-Germer experiment. So electrons were found to give out the same kind of pattern as the X-rays, which was known to be a wave, लाइट वेव ही है, इलेक्ट्रोमैग्नेटिक रेडिएशन ही है एक्सरे. एक्सरे का जो पैटर्न था निकल क्रिस्टल के थ्रू, सेम पैटर्न इलेक्ट्रॉन की बीम से भी ऑब्जर्व किया गया. सो दैट वाज वेव लाइक बिहेवियर ऑफ इलेक्ट्रॉन. एंड द photoelectric effect, which we have already discussed earlier, this shows the particle nature of the light, which was considered as waves till that time. तो उसका भी एक वेव है लाइट, जो उस समय तक समझा जा रहा था एज अ वेव, उसमें भी पार्टिकल लाइक बिहेवियर दिखा, और इलेक्ट्रॉन जो पार्टिकल समझा गया था उसमें वेव लाइक बिहेवियर दिखा. सो इट वाज थॉट दैट दिस इज वेरी फंडामेंटल थिंग. वेव पार्टिकल डुअलिटी इज द वेरी फंडामेंटल प्रॉपर्टी, एंड इसको कहीं ना कहीं जोड़ने की जरूरत है, जो कि डी ब्रॉगली ने किया. Then I have already discussed these points earlier, so not going into much. So refer to my previous classes. Wave particle duality बहुत important है. और then उसके बाद Heisenberg comes in and he gave this uncertainty principle, so which relates to the uncertainty with respect to position, uncertainty in position, uncertainty in momentum, which is, so he gave this concept that no matter how hard you try, you cannot determine the position and momentum with accurately at the same time. Simultaneous determination of, so there will be always be an error of this much amount as given by this equation. Okay, so that was like अगर आपको सिंपल सा कहें कि फैन चल रहा है, आप उसमें बताओ कि ब्लेड की पोजीशन कहाँ है, स्पीड भी उसी समय बताओ, तो आप नहीं बता पाओगे एक साथ. सो दैट इज हाउ. सो उसी तरह से समझिए कि आप इलेक्ट्रॉन एक छोटा सा पार्टिकल है उसको अगर देखने की कोशिश कर रहे हैं, तो जितना छोटी चीज होगी उतना ही आप ब्राइट लाइट यूज करते हैं, एंड उससे वो एनर्जी एब्जॉर्ब करेगा और पोजीशन उसकी चेंज हो जाएगी. सो साइमल्टेनियस, so by the time you are able to locate the position, its momentum will change, energy will change, so something like that thing will happen. So things like, so that has to be also incorporated in the future description of electron. Okay, so ye Heisenberg uncertainty principle and this wave particle duality, all these concepts have को एक मतलब it was taken into account, both these concepts, important concept, uncertainty and the wave particle duality, and then it was used to develop a new so who did this? It was Erwin Schrödinger, who combined all these ideas of Heisenberg and de Broglie together and developed a new theory, which was new mechanics, the quantum mechanics, which even till today we are forms the basic of understanding such systems. Okay, so किसी भी ऐसे सिस्टम को समझने के लिए जो कुछ Schrödinger, it is the role played by Erwin Schrödinger, which is very important. You know, the Schrödinger equation have been already been introduced to you in your classes. So this was the basic. He took into account uh, so this is, so you understand the uncertainty principle. Position of electron is, if you are more precise with the position, you will be less precise with the momentum and vice versa. अब मोमेंटम कैसे पता किया जाता है बताइए. If you I have to know the momentum of an electron, what will be the tool that I will use? Spectroscopy. कहाँ से आएगा? Spectroscopy will tell you about energy. स्पेक्ट्रोस्कोपी से ही तो आएगा, एनर्जी निकलेगा, एनर्जी काइनेटिक एनर्जी से आपने निकाल लिया तो मोमेंटम निकल जाएगा, है ना. सो दिस इज मोमेंटम is related to energy. Kinetic energy is equal to p square by 2m, right? You know this. So momentum is determined once you do spectroscopy. So what is the thing that is happening? It is the spectroscopy that tells you, it tells you about energy, and then you can get to know about potential energy, kinetic energy, and from the kinetic energy you can know about the momentum. समझ गए इस तरह से आपको. सो एक्सपेरिमेंटली दैट, अब आप देखिए विथ पैसेज ऑफ टाइम, इनिशियली आपके पास डिटेक्टर था, द आईज वर द ओनली डिटेक्टर, you didn't have then there was UV and sophisticated instruments were developed, so your precision with energy improved. मतलब आज के डेट में स्पेक्ट्रोस्कोपी बहुत ही एडवांस हो चुकी है. पहले के समय से देखिए तो जितना जो स्पेक्ट्रोस्कोपी में एडवांसमेंट हुआ तो एनर्जी के साथ आपका प्रिसीजन बढ़ गया. यू आर नाउ डिटरमाइनिंग द एनर्जी विथ मोर प्रिसीजन. दैट मीन्स यू आर बीइंग मोर एंड मोर प्रिसाइज विद द मोमेंटम. ठीक है, तो मोमेंटम के बारे में आप बहुत ही ज्यादा प्रिसाइज होते जा रहे हैं. दैट मीन्स ऑब्वियसली द पोजीशन इज लेस डिटरमिन्ड विथ मच लेस प्रिसीजन, राइट. तो इसलिए वी कैन नॉट टॉक अबाउट a circular fixed wire like path, as was the case with the किसके बोर्ड्स मॉडल. ठीक है, are you getting the point? Spectroscopic tools are the basic thing to understand atoms, right? स्पेक्ट्रोस्कोपी में प्राइमरीली आपको क्या पता चलता है? एनर्जी ऑफ द सिस्टम, चेंज इन द एनर्जी ऑफ द सिस्टम, राइट? एनर्जी पता चल गया आपको, काइनेटिक एनर्जी पता चल जाएगी, काइनेटिक एनर्जी से मोमेंटम निकल जाएगा. सो if your resolution improves with respect to energy, you are measuring energy with a high precision. So you are very precise with momentum. Position के बारे में आपको कुछ भी आइडिया नहीं होगा, मतलब you will be becoming less and less precise with the position of the electron. ये factually what this is the fact that what is happening. So हम इंस्ट्रूमेंट बनाते चले गए स्पेक्ट्रोस्कोपी वाले, बहुत ही एडवांस लेवल के, सब में प्रिसीजन एनर्जी को लेके बढ़ गया, मोमेंटम को लेके अच्छा सा खासा प्रिसीजन आ गया, पोजीशन को लेके उतने ही हम अनप्रिसाइज होते चले गए. ठीक है. सो ऐसा अगर है तो हम इट वोंट बी गुड टू टॉक अबाउट इलेक्ट्रॉन मूविंग इन अ फिक्स्ड वायर लाइक पाथ, well defined orbit, and that's what the failure the Bohr's model fails. Okay, so Schrodinger combined the ideas of he combined the ideas of de Broglie and Heisenberg, right? इन दोनों को combine करके he developed a theory which was quantum, a new mechanics was developed to describe the motion of a new mechanics, जो classical mechanics से बिल्कुल अलग, और that was able to explain the entire thing, the behavior of electron in all kind of atoms, whether it's single electron system, multi-electronic system, everything. Okay, so that is the basic. So it started with treating all the motions as wave-like. So that's what I told you in introductory quantum mechanics. That's combining those ideas. He developed a mathematical model which we have already discussed, and it is important to understand that electrons in an atom, whenever you are talking about electron in an atom, the electron is behaving as a standing wave. This is important. Schrodinger assumed the electrons to be behaving as a standing wave. It is wave mechanics, and it is what kind of wave? Standing wave. Remember, this is very important. If you remove the word standing, there is no quantization. So ये बहुत important है, and the ordinary books miss out on this. वही जो if you look at the books written by Indian authors, they most of the time miss out this point. This is very important. If you don't treat the electrons as standing waves, the quantization is gone. There will be continuous change in energy. So what is so special about standing waves? So if you are trying to understand quantum mechanics, you must first of all try to understand what a standing wave is. क्योंकि जितने भी मॉडल्स आप देखेंगे ना, जब आप पार्टिकल इन अ बॉक्स पढ़ रहे हैं या फिर rigid rotor model, whatever, so in all those cases the final equation that comes out to be, it is always a standing wave equation. So electrons that we are taking in this atom, electrons which are part of an atom, which are bound to a nucleus, which are attracted by a positively charged nucleus, they behave as a standing wave. Standing wave का मतलब which is not, over a period of time they are not moving anywhere, they are not traveling. Okay, so well, what is a standing wave? This is important to understand. So you take a string, tie it at both ends, and then if you plug the string, you can generate one loop or two loops, and that is what you know as a standing wave. So this is a common thing while playing with a string. Try to you can generate it. It's a so something like this. So you can see the oscillations happening, but the string is there. It is not moving anywhere. So that is standing wave. There is crest and trough, and then so you know. Let me just uh, so if you understand. So what is standing wave? So electrons were treated as standing wave. So first let's try to understand what is a standing wave. So this one, two, three loops that you can generate in a string. In a normal string, it is very important. We talk about so many things in quantum mechanics, but basic sometimes people miss out on this point. Right. So if you understand the basic nature of standing wave, you will be understanding what happens. So this is standing waves. So you plug the string, you generate one loop or two loops depending on how much force you apply. So you can see the nodes, antinodes in a standing wave at the two ends. So you see, this is a standing wave in one dimension. So if you think of electron as a standing wave in one dimension, this is how you might have what comes to your mind. Okay, so okay, so now what I was telling you, standing wave. So what is the basic feature of a standing wave that we were talking about? Okay, so what you see here, so the two ends are tied, so you must have a zero amplitude at that point. At somewhere in the middle you have, so if you pluck the string, so imagine you have a string tied at both ends. You plug the string with a little force, you generate one loop. So it is something like this. And when you calculate lambda, it is turns out to be, so this is your this length of the string is L. This is the length of the string L. Okay. So and this is one lambda by 2, lambda by 2. So lambda is turning out to be 2L. In the second case, what you see, there are two loops, and here L is equal to lambda. And what you see in the third case, if you pluck it with a much stronger force, so gradually what you see, it then generates 3 loops, and then lambda is 2L by 3. You see one thing, in these standing waves, so this is what you get. This a standing wave cannot have a continuous change in lambda. What either it can be 2L, it can be L, or 2L by 3. So it, the मतलब wavelength continuously change नहीं कर सकता है. It can have a standing wave in a string can have lambda this or this or this value. So if lambda is fixed, that means energy is also fixed. Energy of a standing wave cannot change continuously. It is a basic feature of which we can see in any standing wave. ठीक है? So if you further observe very carefully, what you find here, lambda is 2L by 1. Here the lambda is 2L by 2. What you see here, lambda is 2L by 3. So 1, 2, 3. Or in general, lambda is 2L by n. So this where n is 1, 2, 3. N is equal to 1, 2, 3. So this n is what was called as the integer 1, 2, 3 is called as the quantum number. All standing waves have they cannot have continuous change in lambda, and so if there is no continuous change in lambda, then there cannot be continuous change in energy. This is what we know as quantization. Energy can be either lambda can be either 2L by 1, 2L by 2, or 2L by 3. So energy will accordingly have fixed values. So this is what you are seeing here. When you analyze the standing wave properly, you see, you get the idea of quantization. All standing waves are quantized. So एक डेली लाइफ में एग्जांपल बताइए स्टैंडिंग वेव्स का. स्टैंडिंग वेव का एग्जांपल बताओ. So what is the trend that we see here? What is the trend that you see here? Lambda is cannot change continuously. It can have only. So for intermediate, अगर आप ऐसे सोचिए कि अगर आप कुछ certain energy देंगे एक लूप बना, कुछ दूसरी एनर्जी देंगे दो लूप बनेगा, लेकिन अगर आप बीच की एनर्जी देंगे तो कोई स्टैंडिंग वेव जनरेट ही नहीं होगा स्ट्रिंग में. इसी तरह से 2 और 3 के बीच की कोई अगर एनर्जी से उसको प्लग करते हैं, फोर्स लगाते हैं, देयर विल बी नो स्टैंडिंग वेव जनरेटेड इन द string. So a standing wave has a it can, what we see here, that the wavelength can have only specific values, and so specific values of energy, specific values of wavelength, and so specific values of energy. And this is what we, this is the origin of quantization. This is very basic of. So जैसे ही अब आप सोचिए कि सारे all standing waves are quantized. What we say here, you can make a very bold statement. All standing waves. So ऐसा कुछ नहीं है कि इलेक्ट्रॉन्स की एनर्जी इज क्वांटाइज्ड होगी. बेसिकली स्टैंडिंग वेव्स की एनर्जी क्वांटाइज्ड है और इलेक्ट्रॉन को हम स्टैंडिंग वेव्स की तरह ट्रीट कर रहे हैं. ओके, all standing waves are quantized. We can make a very bold statement and it is correct. और जब आप इसको समझ लेते हैं तो so this is very important thing, that what Schrödinger did in his entire derivation of this mathematical model, he considered electrons to behave as a standing wave, and so जैसे ही वो standing wave उसको treat करता है, the phenomena of quantization automatically comes in, right? All standing waves are quantized because we have just seen that the energy cannot change continuously, right? तो जो भी आप गिटार सितार देखते हैं डेली लाइफ में, एग्जांपल क्या है स्टैंडिंग वेव का? एनी जो गिटार बजाता है, अमन बजाता है, वो सब स्टैंडिंग वेव से भाई। तुम लोग को पहले बताना चाहिए था। स्टैंडिंग वेव्स का एग्जांपल है, एक एक नोट जो है तुम्हारा स्टैंडिंग वेव है, अलग अलग। व्हेन यू प्लग द स्ट्रिंग of your guitar, uh, you generate standing waves each time, and you didn't realize this. My god, student of physics। ठीक है। हाँ हाँ, yes yes yes, all these are examples of standing wave। बट स्ट्रिंग वाला जो है इजीली दिखता है ना, you can see this vibrations, you can see the those things forming। So मेन मेन पॉइंट यही है, और ये मेजर ड्रॉबैक है जो इंडियन ऑथर्स की लिखी हुई बुक्स हैं उसमें ये बात मिसिंग है कि स्टैंडिंग वेव की तरह ट्रीट किया गया। इफ यू रिमूव द वर्ड स्टैंडिंग फ्रॉम दिस ट्रीटमेंट ऑफ इलेक्ट्रॉन एज वेव, नो, you don't get quantization in that। A traveling wave is never quantized, so if I treat electron as a traveling wave, I don't get any quantization, no energy, it will have continuous change in energy। Okay, so that's very important, first point। So अभी आपको जो मैंने दिखाया, that was in a straight line, मतलब it was in a one dimension। We were talking about standing wave। You know, standing wave can be created in a circular frame also, and that will be the closest model that, so you allow for the this uncertainty in position when you do these things, you know, you are doing something like this। So पहले जो wire like path था, you are allowing for the uncertainty in position now in your mechanics that you are developing slowly। So standing wave of electron, if you so let me tell show you one more video। um, एक और इंटरेस्टिंग वीडियो है स्टैंडिंग वेव ऑफ, ओके, सो डू यू सी दिस? ये जो आप देख रहे हैं वाइब्रेशंस, हेलो, you can see nodes and anti-nodes, zero vibration here, zero amplitude, then you have vibration। So this is the closest in a physical frame। अगर लैब में आपको प्रिपेयर करना है कि इलेक्ट्रॉन का मॉडल बताइए, तो ये क्लोजेस्ट nodes, anti-nodes, you see the vibrations। So we can create a standing wave in a circular frame also, and that will be the closest in our thoughts। मतलब ये जो इलेक्ट्रॉन के बारे में हम सोच रहे हैं, ये टू डायमेंशनल स्टैंडिंग वेव हो, टू डायमेंशनल इलेक्ट्रॉन इज एक्चुअली a थ्री डायमेंशनल स्टैंडिंग वेव। You have to now you have to visualize a थ्री डायमेंशनल स्टैंडिंग वेव, ठीक है? तो अब आप सोचिए कि ये जो रिंग में हमने दिखाया सर्कुलर फ्रेम में, ऐसे कई सारे रिंग्स को स्टैक कर दिया जाए एक के ऊपर एक, विच कंटिन्यूअसली डिक्रीजिंग रेडियस, तो एक स्फीयर बन जाएगा, और तब जो वाइब्रेशंस होगी